Alright, so here's just a quick little video on how I approach graphing a velocity versus time graph when given the distance versus time graph. I use this method over here, which says that if you have a curved line on one graph, on the graph below it, it's going to be a diagonal line. If you have a diagonal line on one graph, it's going to be a horizontal line on the graph below it. And if you have a horizontal line, then on the graph below it, it's going to be a horizontal line at 0. So what I mean by this on the graph below it is that usually when given these types of problems, the order goes distance versus time graph first, and then usually below it is the velocity versus time graph. So, so that means that when I say on the graph below it, it would be a diagonal line, then that means that just if I'm using the distance versus time graph, then on the velocity versus time graph, this would be the graph below it. Hopefully that makes sense, but maybe actually doing it will help clarify. So section 1 of the distance versus time graph is just a positive diagonal line. A diagonal line signals that on the graph below it, it will just be a horizontal line. And because it's in the positive direction, the horizontal line is going to be above the x-axis because that signals that it's positive. Section 2 is negative acceleration. That's a curved line. When you have a curved line, then on the graph below it, it's going to be a diagonal. Since this is negative acceleration, it's going to be a negative diagonal line. And this is actually going to run through the x-axis because if you think about this distance versus time graph, say this was a ball being thrown upwards, then at this point right here, that would be where the ball reaches its peak. So that would be the instant when its velocity changes from a velocity in the upwards direction to a velocity in the downwards direction. So as such, that is actually the place where the velocity of the ball equals 0. Section 3 is just a diagonal line in the negative direction. On the graph below it, it would be a horizontal line. Section 4 is a curved line in the upwards direction. A curved line indicates that on the graph below it, it's going to be a diagonal line, and in this case, since it's positive acceleration, it's going to be a positive diagonal line. And then finally, section 5 is just a horizontal line. Horizontal line on one graph indicates that on the graph below it, it's a horizontal line at 0. So it's actually going to be right here. So hopefully this all made sense. This method's pretty handy when you don't really know exactly how to approach a problem. First thing I would suggest is just to split it up into sections. Determine what's going on at each section, and then just look to what you need to do on the graph that's underneath it.